We are going to continue with tweaking parameters. It's been forever. We are looking at exponential functions and what happens whenever you change certain values. So this assignment is tweaking parameters. So on number 1, we changed the start value from 3 to 5. And how that changed the graph was it stretched it. Okay, on number 2, we went from a start value of 3 to a start value of 1. So we actually went down by 2 and it compressed it. Then on this one, we kept the same start value. We just changed the rate. So if it had a rate of 5 compared to a rate of 2, it was compressed. It wasn't increasing as fast. Then number 4, the start value stayed the same, but the rate changed from 5. The rate actually doubled, and it was 10, which made it stretch. It increased a lot faster. So these are all exponential. They don't make a straight line. They go at a curve at an exponential rate. Okay, number 5, we are going to change our start value. So the original start at 3. We are going to start at 8. And our rate is going to be half. So next equals now times 1/2. So we can make a table of values. So on this one, our start would be at 0, 8. I'm going to put the point there, 0, 8, right there. So the rate, the y-intercept was increased. But the rate changed. So let's go to the first one. The rate is half. So that means I'm going to take 8 and I'm going to half it or multiply it times 1/2. So that would be 4. So over 1 up 4. And then our second time, we're going to half again. What is half of 4? 2, 2. And then what's our third one going to be? What is half of 2? 1. So I'm going to do like that. So let's do like that. What would be the one over at -1? If it's halved every time, how can I find out what this one is? To go to -1. Because every time it's being halved. So how would I get the -1, the one before our start value? What's the opposite of having something? Times 2, doubling it. So this would be 16. Let's do -1, 16, like that. So what would be the -2? Positive 32. So -2, 10, 20, 32. Be like right there. Let's find one more. What would be the next one? The -3.
64.
Yeah. Do y'all know how we're getting that? Instead of halving, we're doubling to go the opposite way. So that would be 64. So 64 would be right about there. I'm going to put a little arrow. So what do you notice about this graph compared to this graph? Huh? Yeah, it was like flipped. Flipped over which axis? Which one? Why? Because it's decreasing instead of increasing. So the rate, if the rate is a number less than 1, then it would be halved. I mean, it would be a decrease. So we need to write our new function. So do y'all remember how we write our function rules? Look back at, let's say, number 3. This was 3 times 2 to the x. So where did 3 come from? The first number, where does that come from? The starting value. And where does the rate, or where does this 2 come from?
That's the mean.
Yeah, this rate, the times 2. So what is our start value on this one? 8 times the rate, half, raised to the x value. Okay, so we did the bunnies and the viruses. Remember, the viruses increase exponentially. And then the other one was acorns. Remember the acorns? Each time it tripled because the tree dropped 2 acorns and now it becomes 3. What was the example for a decreasing situation? Do you remember that? Think back to a long time ago. How do, what's a situation where the numbers decrease exponentially? Remember, well, what are we in right now? There's actually a video that we did that showed decreasing.
Oh, like the tournament?
Yeah, like the tournament, March Madness, right? You start with so many teams and half of them get eliminated. Then they get eliminated more and more and more. So every time they lose, they're eliminated. So we go from 64 teams down to 32. So this is kind of the same thing, right? Goes from 64 teams to 32 to 16 to 8 to 4 to 2 to your champion at 1. Let's look at 6. Which changes result in a change in the steepness of a graph? So what changes the steepness of the graph? It's not called slope in exponential. In linear, it's called slope. Yeah, the rate. Rate changes the steepness. So out of all of these, which ones change the steepness or the rate? What numbers? 4 and what?
1.
Let's see, 1. 1 is the same. It's in your now times something. So this one changed the start. This one, yeah. So 3. See how this one was 5 and now it's 2. So 3, 4, and also the one that we just did, number 5. Okay, which changes resulted in a change of the starting value?
Number, what is it? Yeah, 1 or 2.
1, 2, but also we changed it on number 5. Yeah. So 5 had both changes. How does exponential growth compare to linear growth?
Faster.
Grows faster / increases, decreases, or decreases faster. And what does linear do? How does linear grow, increase, or decrease? This increases or decreases by multiplying by a number. But what do you do whenever you're doing linear? How is linear being increased or decreased?
Like pace.
At a pace, yeah, like a constant rate. So it's going to grow by 2 every month or something like that. So this would be more like addition. And if it grows faster, increases faster, this is more like multiplication, repeated multiplication. I can't fit it all on here. So we'll fold this and put it in our journal.